Similar triangles are equiangular, that is, they have the same shape but not necessarily the same size. If two triangles are similar, their corresponding angles would be equal and their corresponding sides would be in the same ratio. So here we have two triangles, triangle ABC and triangle PQR. We are seeing angle A in green, one line, is the same size as angle P with this one line. Then we have angle B with the double lines, is the same size as angle Q with the double lines. And then we have angle C with the triple lines, would be the same size as angle R with the triple lines. So therefore these two triangles, they are equiangular, meaning the corresponding angles, they are equal to each other. And you can clearly see that one triangle is bigger than the other one. Hence they are similar triangles. Now we're going to look at this property where the corresponding sides would be in the same ratio. Now if we look at these two triangles, the side AB corresponds to the side PQ, the side AC corresponds to the side PR, and the side BC corresponds to the side QR. So if I divide the length of AB by the length of PQ, it must be equal to the length of AC divided by the length of PR, which must be equal to the length of BC divided by QR. So notice that AB and PQ were my corresponding sides. See, AB here in black and PQ here in black. So these two sides were corresponding. AC and PR are corresponding sides. We've seen AC in blue and I have the PR here in blue. I have the BC in green here corresponding to the QR in green on this triangle. When I'm looking at the corresponding sides, if I'm putting the length from the bigger triangle as the numerator and then the length of the smaller triangle as the denominator, I must continue that same pattern throughout. So AC would be from the bigger triangle, BC would be from the bigger triangle, PR would be from the smaller triangle, and QR would be from the smaller triangle. Now if I chose to write the PQ first as the numerator over AB, then I must continue that same pattern and put the PR over the AC, which is equal to the QR over BC. So either one would work once you stay consistent with which triangle you are using for the numerator and which one you are using for the denominator. Now when I'm looking at the ratio of the areas of the triangle, meaning the area of triangle ABC divided by the area of triangle PQR, since I have the area of triangle ABC as the numerator, the lengths of the sides of ABC would be the numerator in my ratio. So this would be equal to AB squared divided by PQ squared, which would be equal to AC squared divided by PR squared, which would be equal to BC squared divided by QR squared. Now notice the ratios for the area is just like this. The only difference is the lengths of the sides are squared. Now the first property we're going to look at to prove that two triangles are similar would be angle-angle. And it could be abbreviated to AA, which means angle-angle. So what we are saying here is that angle B is equal in size to angle Q, and angle C is equal in size to angle R. So we don't need to know all three corresponding angles. As long as we have two corresponding angles, that is sufficient enough to say that these two triangles are similar. So my statement will look something like this. Angle B would be equal to angle Q, and that was given in the diagram. Angle C is equal to angle R, and that was also given in the diagram. And this information is sufficient enough to say that these two triangles are similar. So I'll make my statement that triangle ABC is similar to triangle PQR. And now I'll write my reason for saying so, which will be angle-angle. In this question, we have to show that triangle ABC is similar to triangle PQR and hence calculate the length of the side QR. Now looking at these two triangles, I'm seeing that I have corresponding angles. Angle A is 80, angle P is 80. I have angle C here is 60 and angle R is 60. So I'll write angle A is equal to angle P, which is equal to 80 degrees. and that was given in the question. Then I'll write angle C is equal to angle R, which is equal to 60 degrees. And that was also given in the question. Now I have enough information to say that these two triangles are similar. And the reason for these two triangles being similar would be angle, angle. Now that we have shown that the two triangles are similar, we will now calculate the length of the side QR. On both triangles, I have the angles 80 and 60, and this angle at B here is not stated. Likewise, the angle at Q is not stated, and I have the 80 and the 60. So if I draw a line from angle B, it will touch AC, and if I draw a line from angle Q, it will touch PR. So angle B would correspond to angle Q, hence the 15 centimeters will correspond to the 5 centimeters. And if I draw a line from angle A, it will touch 20 centimeters, which is BC, and angle A is 80 degrees. So if I draw a line from angle P, which is 80 degrees here, it will touch QR, which is the length of the side we want to find. I'll put AC over PR. That's because I know the length of AC and I know the length of PR, and AC and PR are corresponding sides. Then I'll put it equal to my next two corresponding sides, which will be BC and QR. So I'll write BC divided by QR. Now I'll put in the lengths of the sides. So AC is 15, PR is 5, and that's equal to BC, which is 20, divided by QR, which is what we want to find. So I'll say 5 into 5, 1, and 5 into 15, 3. So I'll get 3 over 1 is equal to 20 over QR. Now I'll cross multiply, and I'll have 3 multiplied by QR. That will give 3 times QR. And I'll have 1 multiplied by 20, and that will give 20. So now this is 3 multiplied by QR. I'll transfer this positive 3 across the equal sign, and the operation will change from multiplication to division, and I'll get 20 divided by 3. And I'll get QR is equal to 20 divided by 3. So that will work out to 6 2/3 centimeters. Now that we have already proven that these two triangles are similar, we want to look at this question here. We're given that the area of triangle PQR is 30 centimeters squared. We want to calculate the area of triangle ABC. So before I start the question, I would make a substitution, and I'll let X represent the area of triangle ABC. I'm making the substitution because I want to calculate the area of triangle ABC. Now, seeing that I have the area of triangle ABC as the numerator, and then the area of triangle PQR as the denominator, I would write AC squared divided by PR squared. So now the area of triangle ABC would be represented by X, and the area of PQR would be 30 centimeters squared, and that will be equal to AC squared, which is 15 squared, divided by PR squared, which is 5 squared. So I'll have X over 30 is equal to 15 squared is 225, and 5 squared is 25. Now 25 can go into 225 9 times. So now I'll have X over 30 is equal to 9 over 1. So now I'll cross multiply. So I'll multiply X times 1, and that will give us X. And I'll multiply 30 by 9, and that will give us 270. So recall that X is representing the area of triangle ABC. So therefore, the area of triangle ABC is equal to 270 centimeters squared. The second property to prove that two triangles are similar would be side, 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 abbreviated SSS for side, side, side. So in this question, we're going to show that triangle ABC is similar to triangle PQR. Hence, we're going to state the value of the angle Q. Now, when you're approaching a question like this, your corresponding sides must give the same ratio. So if I take 8 and divide it by 4, I'll get 2. If I take 12 and divide it by 6, I'll get 2. So that tells me that 8 corresponds to 4, 12 corresponds to 6. So likewise, if I take 20 and divide it by 10, I'll get 2. Therefore, BC corresponds to QR because my ratio is the same for all three sides. So I'll have AB over PQ is equal to 8 over 4, which is equal to 2. And I also have AC divided by PR, which is equal to 12 divided by 6, which is equal to 2. And I'll have BC divided by QR, which is equal to 20 divided by 10, which is also equal to 2. So I can clearly see the ratio of my 3 corresponding sides are the same. Hence, side, side, side. So I'll make my statement that triangle ABC is similar to triangle PQR, and my reason would be side, side, side. Now to state the value of angle Q. So I'll draw a line from angle Q to see which side it touches. And angle Q is opposite PR, which is 6 centimeters. On triangle ABC, the corresponding side to PR would be AC. So if you draw a line from AC to see which angle it touches, it will touch angle B, which is 20 degrees. So the 20-degree angle is opposite to the side AC, which is 12 centimeters. Therefore, angle B would correspond to angle Q. Hence, angle Q would be equal to 20 degrees. The third property to prove that two triangles are similar would be side angle side, abbreviated SAS, side angle side. Now notice the angle is in between the two sides. So the side would mean that the ratios of the corresponding sides are equal to each other, and the angle would be in between the corresponding sides. So when we look at triangle ABC and triangle PQR, if I say 55 divided by 11, I'll get 5. And if I say 50 divided by 10, I would get 5. Therefore, this side AB being 55 centimeters would correspond to PQ being 11 centimeters. And AC being 50 centimeters would correspond to PR being 10 centimeters. Now the 40-degree angle is in between the corresponding sides, not the 60-degree angle. The 40-degree angle is in between the corresponding sides. So I'll say AB divided by PQ is equal to 55 divided by 11, which is 5. And then I'll have AC divided by PR, which would be 50 divided by 10, which will also be 5. So I have the ratios of my corresponding sides being equal to each other. Then I'll have angle A is equal to angle P, which is equal to 40 degrees. And that was given by the question. So now I have enough information to say that these two triangles are similar. We have the ratios of the corresponding sides being equal to 5. And we have 2 of them, and the 40-degree angle is in between the corresponding sides. So I made my statement now that triangle ABC is similar to triangle PQR, and my reason would be side angle side.